people have some programming experience, but since there are people that don't have any programming experience, I will try to simplify things a lot. And to teach you, and my goal here right now is to give you a really big bird's eye view of just basic programming syntax and how to do them in Python. And let me just write stuff down. So the goal for today is get a bird's eye view of a basic Python syntax. And if you go away remembering what a for loop is or what a variable is, and a couple of data structures like lists or dictionaries, which is just very little, I would consider that a success. I don't expect you guys to remember anything much or just really master anything. That comes with a lot of practice. And we will do practical sessions when I have finished preparing them, where we will solve problems together. So basically, I'm going to try to teach you all of this very simply. And next, on the next session, I will teach you how to use these things to write programs and solve problems. And finally, setting up a local development environment. I did find that the beginner courses were very lacking on this, and that led to a lot of headaches when I was trying to study and do projects on my own. So this is what you can expect. So yeah, with that out of the way, let's start. So many beginner courses, they start with the hello world. This will just teach you that you can tell a computer to do something, and the computer will do it. And this print is called a function, and a function is just essentially a black box that is there that you can either create or that's already there. And if you tell it to do something, it will just essentially just do it. It will just, yeah. And if we just run this, it will get a hello world, and that is just very basic. We wrote a program, the computer compiled it and interpreted it and just executed it. And that's what essentially what programming it is. If you've ever wrote instructions for people to follow, or you have followed instructions yourselves, then it is essentially what programming is. Has anybody followed instructions that were written down? Has anybody? Okay. Has anybody else given instructions that were written down and expected people to follow them? I guess all of you have somewhat done something like that, and that is essentially what programming is. And programming, you have to write instructions in a very specific, very certain kind of way. And it differs from language to language, but the basic principles are the same, as I will show you. So the first thing I'll introduce you to is the concepts of variables and types. Variables are essentially telling the computer, hey, remember this, right? Remember that the variable a, when we call upon it later, you have to give back the number 20. So we're saying, hey, remember this. Hey, computer, we're going to say a is 20. If you've guys done math before, like basic middle school level algebra, where we put, say, x is 1 or x is 2, this is essentially the same. We are telling the computer to remember something, and this is the variable. And most programs just start by telling the computer to remember something and then execute it later. And the second concept I want to introduce is the data types. So if you've guys seen the matrix, you've seen all the zeros and ones come down the screen. Computers mostly think in binary, and but as humans we don't. But we do need to tell the computer to do things somehow. And the compromise that we came up with between zeros and ones and the many kinds of information that we can tell the computer what to do is data types. So there are 4 main data types in Python. First is an integer, which is just a number like this, like 20. And float, this is numbers with decimals, so 20.99. And string is just text like this. And we put it in double quotation marks. And a Boolean, so true and false. This is the actual like most simple like 0, 1 kind of like data type there. And when we tell the computer to print this, the computer will go, okay, so A, we told the computer that, hey, A is 20. So when we tell the computer to print A, it will print 20. When we tell the computer to print B, it will print 20.99. And when we tell the computer to print C, it will print 20, and so on and so forth. So if you run this, we get that. Is everybody following on so far? Has anything I've been saying kind of confusing or weird? Nothing? Okay, cool. And the next part. It's just basic arithmetic. A lot of people worry that if you want to do programming, you need to be good at math. Unless you are in certain fields like artificial intelligence, machine learning, or computer graphics, you really don't need a lot of complicated math. The most you will need is just basic arithmetic that you will learn in primary and middle school. And the computer is just really good at this kind of stuff, so it does it really, really fast. So we have addition, we have subtraction, we have multiplication, division, and this is a power, so 3 to the power of 2. And this is 10 divided by 3, but without the remainder, right? So I'll print this. So 1 plus 1 is 2, 2 minus 1 is 1, 2 times 2 is 4, and 4 divided by 2 is 2.0. So Python will automatically convert between data types between integer and floats to make things easier for the programmer, because mostly in other languages they throw a really big fuss if you try to mix data types together. But Python is kind of easy in that way. So next is 3 to the power of 2, you get 9, and 10 divided by 3. So 3 goes inside 10 3 times, so you get the answer 3. So this is like how you do basic arithmetic, and this it will be useful in the future. So this is how you do that. So now that I told you about data types and basic arithmetic, we can start to do things that can cause errors. Errors are just a computer's way of telling, hey, the thing that you told me to do, it doesn't work, and I'm just going to stop right there. So I told you that in Python, there is automatic type conversion between integer and float. And when we do this, the program, it will just run fine. 20 plus 20.99, we get this number. It works fine. But when we try to do something that is just like just really, really wrong. So trying to add a number to a string, let's do a text. You may just think that Python will just go when we add them together to print something like this, but that doesn't work because internally a computer stores things like numbers and characters and text very, very differently. So if you try to do this, the computer will throw an exception. Just say, yeah, unsupported operand type. So it says we can't add integers and strings together. For some reason, it seems like that you're raising your hand, but you're not. So I'm just constantly going that way. No, it's fine, yeah. So what do you do when you may do something that will cause an exception? So we will try the same thing as above, a plus c. We will try this, and except any exception, we will print there was an error. And then after everything is done, we will just do something else. So we'll try this. If there's an error, we'll do this. And when everything's over, we'll do this. This is what this program does. Yeah, so there was an error, so we just added 20 to 20 again, so we got a 40. So this is how we handle failures in programs in a more elegant way. Am I going too fast, or did anything that I say was not clear? Please tell me. No. Okay, then I will go as I will continue. So the other sets of operations that you can do is comparisons. So comparisons results in a Boolean value. A Boolean value, to remind you, is stuff like true and false. False. Right? And stuff like arithmetic and comparison, it will be useful later when we talk about loops and other functions like that. And functions, yeah. So this is just greater than. This is the greater than symbol. Greater than or equal to. Less than or equal to. If you've done just primary school math, these will be very familiar to you. And if we want to see the results of this, we will run this. We'll see true, 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 false, 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 true. Yeah. And you can only really compare between data types that match each other. So right now I've only compared integers to integers. But if you try to compare like a integer to a string or a Boolean, it won't really work. Integer and float can't work because Python just converts the integer to a float for you. But if you try with something else, it will not work. Another aspect of Python programming is logical operators. So there are mainly two operators that you need to know. There is the AND and the OR. So to demonstrate what ANDs and ORs do, first starting with AND, the results of this is also a Boolean value, like the comparisons above. So as you can see, true and true equals to true, and true and false equals to false, and false equals to false. So this shows you that both the left and the right need to be true in order for the result to be true. Next is OR. So the left is true, right is true, left is true, right is false. So if you print this to see the result, we go true, true, and false. So as you can see in OR, only one side needs to be true for the entire thing to be true. So yes, so this is just basic ways for the computer to tell the basic ways for to implement logic in your program by comparisons, by addition and subtraction, and by these logical operators. So the most math you really need to know is just stuff like this, and in a mathematical sort of logical way of thinking. So you guys have all done middle school maths, right? I hope so. Yeah. So now we get to see how these comparison operators and Boolean stuff can be used in a program to write actual more complicated logic. We will start with control flow. This is a concept called control flow, and so as I've told you, this comparison operator it results in a Boolean, and this if it will do something as long as this condition is equal to true. So 20 is larger than 10. So if we do this, it will print this. No, right? And when we assign variables and do this, we can see that we can implement more complex logic. So if you do this right now, A is larger than B. We can just know by just seeing this, but the computer doesn't, so we have to tell them. If we swap them around, b is larger than a. And more astute listeners will be able to observe that what if b and a and b are the same? That means no, this is wrong because they are the same. But we've only told them to compare b is larger than a. We haven't taken account for the fact that b and a could be the same. So this improved control flow. So if in the first thing it only compared if b is larger than a, and for all other conditions it printed a is larger than b. But what if we want more? What if you want more complicated logic? So if b is larger than a, b is larger than a. Else if, elif is short for else if, right? It will print b is equal to a. And the final case will be a is larger than b. So if you print this right now, we get the correct answer that b is equal to a. Yeah. So this is basic control flow. Was anything I said unclear? No? No. Okay. Now, I've mostly talked about simple data structures, or maybe not even data structures, just simple types of data, like just integers and floats and strings and booleans. But just trying to work with this is very limiting when we want to do more complicated stuff. So I will introduce you to the concept of data structures. And data structures are a way to store data inside the memory of a computer. So right now, the computer can only remember one thing at a time. But we want to remember multiple things at a time. And there are many ways to do that. Many ways. So the first is a list. A second is a tuple. And the final sort of like list-like, which is like consecutive things, is a set. So the list is just a list of things, like a shopping list or like I don't know, a to-do list. You just store things inside to these two square brackets, right? They can be a list of ints, list of floats, list of strings. And yeah, you can add things to it, you can remove things, you can cut lists into halves and just smaller pieces as you wish. A tuple is like a list, but you can't change any values inside it. Once you define it like this, you can't really add or like remove things to my knowledge. And they are defined by this just normal round brackets, right? And finally, we have things called sets. Sets are unique in that there can't be any duplicate values inside sets. So normally, we can do stuff like this for lists and even for tuples. But if you try to do this, I'll try to print set A. It will remove the duplicate. So if you've done studied maybe like Venn diagrams or sets in school, this is essentially the same thing. Yes. Does everybody know what a Venn diagram is? Okay. Now, what do we do with these kind of more advanced data structures and all these logical operations above? We can start looping and thus looping over things. So computers are just really good at doing repetitive things really fast over and over again. It will never complain about like the weather or how hungry they are or whatever. They will never get bored. So they're just really good at repeating things. And there are many ways to repeat things in the computer in programming. And I will introduce you to two concepts called fors and while loops. So, right. So this thing is a for loop. So I'll just show you what it does. It repeated hello world 10 times. We told it to repeat it 10 times. So what this is a function that will return something very similar to a data structure that looks like this. Right? It tells you that, so the computer basically said, oh, so for how long or large this this data structure is, although it's not actually a data structure, it will repeat that this many times, right? And we can loop over things inside the data structure that I just explained to you above. So we have this list of integers 1, 2, and 3, and it will print these numbers. So for I in the list A, we will print I. It'll print 1, 2, and 3. And another way to repeat things is called the while loop. So for a for loop, the end of the repetition is just very fixed. It will do stuff as long as there's stuff in this list right now. But for a while loop, it's different. You have to explicitly set the endpoint yourself. So right now I is 0. We say I is 0, and while I is less than 5, this will always be true because I is 0 right now. It will print I. So if I do this, it will just keep printing it. It will just keep printing this. Yeah, let me just reload. Right. So what we have to do here is the basic arithmetic that I told you above. We will say I is I plus 1. So we are reassigning the variable to another value. So we're telling the computer, hey, right now I used to be 0, but it's going to be 1 right now, right? And we're going to do that every single time until I is no longer less than 5. So this will stop when I is exactly 5. Oh wait, no, it starts from 0, sorry. So it ends at 4, right? So this is the main difference between a for loop and a while loop. You have to set the explicit stop point yourself, or and for just for loops, you can just depend on the data structure for the loop to end, right? And I will show you many things that you can do with the list, like adding, extending, reversing, blah, blah, blah. I don't expect you to remember all this, but these are the things that you can do, right? So for lists, right now, the list A, we have values 1, 2, and 3. But what if we want to see just the first element? So the first element of the list, what if you just want to see the first? We can use this notation. So these are square brackets, and this is the index. This is called the index, which is basically the number that is assigned to just each data in the list. And computers, they start counting from 0, mostly. Some programming languages, they start counting from 1, but most of the time, we will start counting with 0. So we will print a 0, we will get the number 1. What if you want to add things to the list? We use the function append, right? We will add 4 to the list, and we will get 1, 2, 3, and 4. But what if you don't want to add things one at a time? What if you want to add things 2 or 3 things at a time? We'll use the function called extend, and as you can see here, we put another list inside with numbers 5 and 6, and we will end up with 1, 2, 3, 4, 5, 6. Right. But what if you want to reverse it? Well, it's simple. If English is your first language, then Python will be a lot easier for you because a lot of the words are just very self-explanatory, the things you want to do. So if you want to Google, how do I reverse a list? Python, a built-in function called reverse. If we do this, it will be reversed. And you don't need to remember all this. I certainly don't. I forget a lot of times and I just Google them. So there are just there's basically like useful sites that just tell you that, oh, these are the things that you can do with Python lists, right? And as you use them, enough, you will just naturally remember them. So don't try to like take notes and memorize it like it's a test at a school. As long as you can do it, you can do it. And what if you want to sort the elements inside the list? You'll use the sort function. Right now it's been reversed, but what if you want to sort it in ascending order again? So we'll do sort, go print A. So we'll go 1, 2, 3, 4, 5, 6. So these are the things that you can do with a list. Right. So tuples. Not many things you can do with tuples because once you define them, tell the computer, hey, this is going to be a tuple and there's going to be elements 1, 2, and 3 inside them. You can't really do much. You can just say how many of these things are inside a tuple, and what's the index of this element inside this data structure. We run this. We're counting how many trues, the value true, exists inside this tuple, and there are 2, so it will result in 2. This index, so where is it inside the tuple? So we use the index function and we get 0. It's in the 0th element of the tuple, so we get this. And sets are basically Venn diagrams. And things we can do are, so we have the set A, and we're going to update it with another set called 3 and 4. And we get the 1, 2, 3, and 4 because duplicates are because they're not allowed, right? And we have we defined another set here called A1, and they have the elements 3, 4, and 5. And we're going to get intersection between A and A1. So we're trying to find common elements between sets A and A1. So when we print this, we will get 3 and 4 because 3 and 4 are the common elements between 3, 4, 5, and 1, 2, 3, 4. And when we want to add things to the set, instead of the append, like in the list above, we use the keyword add. So when you do this, nothing's going to happen because we already have the element 4 inside the list. But if we do this, we'll get 1, 2, 3, 4, 5 because 5 does not exist in the 1, 2, 3, 4. So this is what you can do with sets. Am I going too fast? No, okay. I have done this example before. No, I've done this example before, but not this. So, question? Okay. I think it's remove, I believe. Yeah, there are a lot more, but I cut down on the examples. Hold on. There is a remove, yeah. Remove the specified element. Yeah, there is a lot of stuff that you can do with sets, but I did one, yeah. Hold on. So so I already told you how to just index things inside the inside a list like, or just a data structure like this, a simple data structure, and it starts with 0 and 1 and 2 and 3. But what if you don't want to just type it all out like that, right? Then you can do this. So in the range, which is the length of A, right? So the length will be 3, and we will be start counting from 0 and 1 and 2. We will get, so this basically becomes the index of the elements in the array, and when we put it in here, right, we will get 1, 2, and 3, right? But what if you want to skip the first element, which starts at 0? We can use the control flow here and the continue keyword. This continue keyword will tell the computer to to just skip over this iteration, this loop. So if we do this, we will get 2 and 3. So yeah, so this is a way of slowly combining the things that we've learned. There's a logical operator, there's loop, and there's just indexing in a list. And another way to combine things we have learned is, so in the example above, I reassigned I, like doing this, I equals I plus 1. I guess programmers found this kind of cumbersome to write, because we have another way to do the same thing, which is plus equals. And like the arithmetic operators that I showed you above, like minus and multiplication, if you do this, this is essentially the same thing as b equals b minus 1 minus 1, or b equals b times 2, which is essentially the same as just using this. Semantically not completely the same as doing this, right? These two are just identical. And so this is the same condition as above. So while b is less than 5, we will print this, right? We do this, we will do in a while loop 5 times. But what if you want to break it at a much earlier time? What if we want to make the loop stop? Then we do this. So instead of I, it should be b. Yeah. So it's going to keep adding 1 at the end after printing in a while loop. And when b is 3, this keyword break will forcibly break the program out of the loop that is in. So if we print this, you'll only do it 3 times. So this break and continue, it could be useful later when we write programs, right? So we dealt with a lot of numbers and just comparisons and loops. We're going to go back to text. So text is stored differently than a number inside a computer, and because of that, we can't do the same kind of operations that we do on numbers, on strings. So we have to do things a bit differently. And I think a smarter way to think about these strings is essentially, a list of single character strings. Right? Because as I told you above, how we access elements inside the list is by using this square bracket keyword, not keyword, but like square bracket notation here, and we do the same thing with strings here, right? So another way to think about just this is just basically this, right? So we told the computer to remember, hey, A is called a CoolString, right? Just gonna print a CoolString. Thing you can do with strings is replacing things. So we're gonna replace this if the word string appears inside this string, right? We'll replace it with dog, and we print this, we'll get a cool dog, right? And another thing that you will do a lot with strings is string splicing. So this means that starting from the 0th position, which is A, we'll go up to 6. So when we print this, the 6th position. So starting from A, this is 0. This space is 1. This is 2, 3, 4, and 5. So not including the final number. We'll do this. We'll print out that. And you can do the same thing with lists, but I felt like I showed you way too many things that you can do with lists, so I didn't want to overwhelm you guys. So this thing is called splicing, and you will do a lot of it when you write programs in Python and just in many other languages. And while you can't add strings and numbers together, text and numbers together, you can certainly add strings together. And when you do this, you'll get the first element of the string, which is going to be the character A, and we're going to add this string to the end of it. So we'll print a parrot. You can't do this, I believe. No, it will throw an error. It's not supported between string and strings. You can only really add things and just replace things. And if you want to remove stuff, you can just slice them. Just like slicing is just like slicing a ribbon or a piece of paper. You can just like cut them up, right? So these are the things that you can do with strings. So another cool feature that I want to show you is stuff like this. Right now, I showed you a way to glue strings together using the plus operator, but there are other ways to do it. We're telling the computer to remember, hey, B is going to be the string called cats, right? And we're assigning, and we're saying that I want to put B inside the string, but I don't know what B is, right? So I'll just put it like this. So instead of a normal string where we put these two double quotation marks, right? We have to indicate that this is a F string. So we put this F keyword here, and then these two squiggly brackets. And inside these two squiggly brackets, we can put inside variables like this. Right? So we print this. It says I like to pet cats, and this is essentially called a F string because it's a string with the F in front of it. Another side note: I've been using mainly like one character variable names, but in Python we use things when variable names get longer. We use a way of typing called snake case. So the names, the words are separated by underscores. And this is just a convention that most Python programmers follow. You don't have to, but this consistency will just make things easier to read. Because you can certainly do stuff like, this is called camel chase. And you can do stuff like this, but we mostly do this. In other languages, you do use a naming convention like camel chase, but this is just a tangent, right? And finally, all these things that we've been using, like print and replace and range and length, they're all basically things called functions. And functions are they're a way to abstract repetitive things that you want to do inside a nice package, and say, hey, remember that when I do this, I want you to do something else. So we've been mostly telling the computer to remember things and just printing them out later and just comparing things. But if you want to store more complex instructions inside something, we do something like functions. And right now I'm going to start with something a bit simpler. Add one number. So this is a very contrived, simple example, but we're telling, hey, computer, when I use this function, add 1, take the number and add 1 to it and print it out, which is basically a set of instructions. So if you do this, add 1, and I put in the number 10, right? It will get the result of 11, right? And it's a way of storing instructions so that you can call them later, right? Is the concept of functions confusing to anybody? No? Okay. So finally, so to use more official programming terms, the thing that the function takes is called a parameter, right? And the thing that you put inside a function is called an argument. I do get them confused all the time, so I did have to look it up. So what this function does, it takes a parameter, it adds it to this f string, and then it prints it out, right? Prints it out, and we're gonna put in the argument called pizza inside this function, and what you're gonna see is the instruction that we wrote being executed. Oh, I like pizza, right? Another way to elaborate on functions more. But what if you don't want to just print things out, right? Or you don't want to print things out, right? No. Another keyword I will show you is called the return statement. It will return the results of this function, which in this case is called CoolString. And what we can do is assign the results of this to a variable. All this variable assignment that I showed you above, it comes back. Result of the function will be the same thing. Instead of pizza, let's go with burgers, right? You do this. At first, the burgers, it goes into the function, it gets added to the f string, and then it gets returned, right? And then it gets reassigned to the variable called result of a function, and then we print it out to see. So this is a way to just chain things together if you just by using the return keyword, right? And the final thing that I would like to in this crash course that I would like to explain to you guys. Wait, before I go on, was there any part that was not clear or that you would like me to go over again much slower? Nothing? Nothing. Okay. I don't expect you guys to completely master this or remember this. We will solve questions together later in another session, right? It's a thing. So the final thing that I would like to talk about in this just crash course is a thing called classes. Classes and objects. It's a really big topic itself of using classes and objects to program, and it is the more abstract concept. So it may be a bit difficult for you guys to intuitively understand. So a class, my class. I'm not sure if this will be a good idea to just explain, but no, let's go with cookie. Yeah, right. So do you guys all know what a cookie cutter is? It's basically a metal kind of shape. It's metal shape. It's round. And when you put it on a cookie dough, you can make dough in the shape of cookies. I like to compare classes to cookie cutters because essentially you can create things called objects using classes. And this class is a cookie cutter, and the object is the cookie, right? So if I go cookie 1, I'll say this cookie will have the name chocolate chip, right? So it will create something called an instance of a class, which is an object, and assign it to the variable cookie, right? We print this. This is the object that got created by using this class, right? You don't need to know what this is, but this is basically it. And by using this example, I can teach you a couple more concepts that you don't really need to remember right now. So the first is the concept of self. So this cookie, it takes the name, it takes this parameter, like the function above, because this is a function. When we use when we define functions, we use the keyword def. I even forgot to tell you about that. Yeah, but we use the keyword def to define functions. And when we take the name parameter, this argument, we will say, hey, so I will take this, and I will remember that my name, so my name is the one that I got. So right now, I gave the name chocolate chip to this cookie. So if I print cookie.name, you'll get chocolate chip, right? We told the cookie to remember that its name is chocolate chip, right? And that's the first concept, self, that I told you. And the second is dunder methods. When we did this, right? When we did this, we didn't do cookie dot, init. We didn't do this, right? When we just use the brackets, this automatically called this function, right? So there is a lot working under the hood in Python to get you to do what it wants, and there are these things called dunder methods that Python just calls by itself, and you don't need to really memorize or just think about these. They will just magically do it for you at this stage, and you will learn about them when you specifically need them. So you just have to know that these things exist, and these are some of the things that allow the magic of Python to happen, right? So the concept of cookie cutters, that's the class, and we can make more stuff, and we can make objects using a class. So we can do like multiple things. Cookie 2. We'll go, oatmeal. So we made another object, another instance of the class, and we assigned it to cookie 2, and this is going to be oatmeal cookie, right? And I'm not going to go any more further than this about classes, because it's a very complicated topic that beginners may get really confused about, because this was already a lot of information. Another data structure, and another thing that I want to talk about right now is a more complex data structure. Right now, we only did simple, like linear data structures, like this. But another data structure that could be useful, which I didn't include this here because I wasn't sure if I had enough time to go over everything, is called a dictionary. Right. When we think of a dictionary, if we could think of a book or like something on your phone. How we use a dictionary is we find the word that we want to know the meaning of inside the dictionary, and we get the meaning of it when we find the word. And a dictionary data structure in Python works very similarly to that. So dictionary 1. So it could be confusing because for sets we also use these squiggly notations, But in dictionaries, how we define the data inside is different. So, so we will go right. So what I've done here is say, so in this dictionary, the first element is going to be a key value pair. This is going to be the key, and this is going to be the value. And what the keys and the values do, it's going to be apparent when I show you how this is used. So when I ask a dictionary, what is Jason? It's going to respond, Jason is a human person, right? So this thing is called a key, and this thing is called a value. And there are other operations that you can do, but I already think it's too much that we covered, so I won't go into too much detail. But this is a way to store like paired values. And the keys and the values, they don't essentially have to be strings. They can be even more complex data structures, like as complex or simple as you want. So it can be numbers, like that. So the key is going to be a number, and the value is going to be 100. 100. Yeah. We can even store lists inside dictionaries, right? And we separate each key and value with commas, right? And when we want to access things inside the list, we use the square brackets. Square brackets gets used very often inside Python. So when we access the value, when we want to access the value of 100, we use the key 100. When we do this, yeah, we get 100. Yeah. And this is a dictionary. You can loop over the keys inside a dictionary, and you can also loop over the values inside a dictionary. You can loop over both of them at the same time, and all that kind of stuff. And yeah, but what if we want to assign things after we define them? Right? We use the same square brackets keyword and the assignment operator under value. When we print the dictionary, we'll see that this got added. This another key, another value got added. You can also remove things. Yeah, another key, another value. By using the del keyword, del. We will remove 100. We will print dictionary again. And we will see that the key value pair 100 got removed, right? Up here we still have it, down here we still don't have. So yeah, these are I guess a bit more complex things that I was unsure about adding, but since we had time that I did add. Are there any things that wasn't clear, or you would like for me to go over again? Or feedback helps, guys. Yeah. Do you have a question? Yeah. 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 In the context of a loop, it stops the loop. It can also, hold on, I don't remember exactly. I've only used them in breaks, in loops, in breaking loops. Let me just check. Python break. I don't think I've ever used them to stop a program, I think. Yeah, it's only used in loops. Yeah, there are other ways to stop a program, and break isn't one of them. Yeah. Any other questions? Any more clarifications that you guys need? the completely unexperienced people, do you have any confusions or nothing? Okay. That is the crash course. That is everything. Thank you for listening. And I do hope you guys come to the next session where we will actually do stuff with all these things that we've learned. I've only taught you what the ingredients are and the basics of using them, but we will take the ingredients together and try to solve problems in a programmatic fashion. Because just knowing this is enough to get you started, but you do need a certain way of thinking, of approaching programming problems and just breaking them down and doing step by step. Because I found that just expecting the computer to act like a human is a mindset that a lot of people come to programming with, and that just really just throws them for a loop, because yeah, that's just not how a computer works. A computer works by taking very specific, very clear instructions, and you need to think in those kind of terms, right? So thank you for listening. This has been the Python Crash Course.